Chapter 10. Air and Water. Let's begin. The Earth is the only planet that is suitable for life. The presence of air and water makes life possible here. One cannot survive without these essential resources. Air. Air is all around us, even though we can't see it. However, we can feel it when it moves. For instance, when the wind blows, it makes the leaves on trees rustle, clothes on a clothesline sway, and loose objects get blown away to different places. All living things, including humans, animals and plants, need air to survive. Composition of air. Air is a mixture of several gases. The two main gases are nitrogen 78% and oxygen 21%. The remaining 1% consists of gases like carbon dioxide, neon, argon and ozone, along with water vapor, dust and smoke. Oxygen. It is essential for life. All living organisms need oxygen to breathe. It is also necessary for burning combustion. Nitrogen. Although nitrogen makes up most of the air, plants and animals cannot use it directly. Plants absorb nitrogen from the soil, while animals get it from food. Nitrogen does not support burning. Carbon dioxide. It is used by plants in photosynthesis to make their food. It is also used in fire extinguishers. Other gases. Air contains small amounts of gases like neon, argon, hydrogen and helium. Argon is less colorless and odorless gas which is used in making electric lights and tubes. Helium is very light gas that is used to fill balloons. Water vapor. It forms when water evaporates from oceans and lakes. It plays a role in weather, forming clouds and rain. The amount of water vapor in air is called humidity, which makes the air feel humid or dry. Let's do experiment. Aim. To show oxygen is required for burning. Materials required: 2 candles. A beaker. Steps. Take 2 candles and fix them on a table. Light both the candles. Fig A. Now, cover one burning candle with an inverted beaker. The beaker should not touch the flame. Observation. After some time, you observe that the candle covered with the beaker stops burning. The other candle continues to burn. Fig B. Why does the candle in the beaker stop burning? The candle in the beaker stops burning because when the burning candle is covered with the beaker, the oxygen supply from the air is cut off. Once all the oxygen inside the beaker is used up, the candle stops burning. The other candle continues to burn because it gets oxygen from the air. This shows that air oxygen is necessary for burning. Atmosphere. The atmosphere is a thick layer of air that surrounds the Earth. It is held in place by the Earth's gravitational force, which keeps the air close to the surface. The atmosphere reaches up to about 800 kilometers above the Earth. However, as we go higher, the amount of air becomes less. That's why mountaineers carry oxygen cylinders when they climb high mountains. Importance of atmosphere. The atmosphere contains oxygen, which is essential for living things to stay alive. It helps to keep the Earth warm by trapping heat, making it suitable for living things. The atmosphere burns up most meteors before they can reach the Earth's surface. It protects us from the sun's harmful ultraviolet UV rays, which can cause health problems. Info Corner. Meteoroids are small rocks, moving in space. They may be harmful to us if hit the Earth's surface. Layers of atmosphere. The atmosphere is made up of 5 main layers, each with its own special features. 1. Troposphere. It is the lowermost layer of the atmosphere. It lies up to 15 kilometers above the Earth's surface. It consists of about 80% of all the air in the atmosphere. All weather changes take place in this layer. 2. Stratosphere. The layer above the troposphere is the stratosphere. This layer extends from 15 kilometers to 50 kilometers above the Earth's surface. No weather condition exists here. This layer is often used for air travel. Aircrafts fly. The ozone layer that protects the Earth from the harmful ultraviolet rays of the sun lies in this layer. 3. Mesosphere. It is the third layer of the atmosphere. It extends about 50 kilometers to 80 kilometers above the Earth's surface. Meteorites or meteors, piece of rocks that enter into the Earth's atmosphere, burn out in this layer, hence are unable to reach the Earth. 4. Thermosphere. It is the fourth layer of the atmosphere. It extends from 80 kilometers to 500 kilometers above the Earth's surface. Space shuttles use this layer for orbiting the Earth. 5. Exosphere. It is the fifth and outermost layer of the atmosphere. There is no air present in this layer. Atmosphere gets merged from here into the outer space. Properties of air. Air occupies space. Air is a form of matter, which means it occupies space. Let's look at a simple experiment to understand how air occupies space. Let's do experiment. Materials required: an empty glass, a bucket filled with water about 3/4 full. Steps: take the empty glass and quickly turn it upside down and place it into the water-filled bucket, keeping the glass straight and upside down. Observation: you will notice that the water does not enter the inverted glass. Why? This happens because the air occupies the space, blocking the water. Now, slightly tilt the glass. As you do this, you will see air bubbles coming out of the glass. As the air escapes, water begins to enter the glass. Conclusion: this shows that the glass, which may seem empty, is actually filled with air. It proves that air occupies space. Air has weight. Have you ever wondered if air has weight? Let's perform a simple experiment to find out. Let's do experiment. Materials required: 2 balloons of the same size, a piece of string, a stick, a needle or pin. Inflate both balloons to the same size. Tie a piece of string in the middle of a stick and attach each balloon to the ends of the stick. Carefully balance the stick by adjusting the position of the balloons so that the stick is level. This shows that the weight on both sides is equal when the balloons are inflated. Fig A. Now, take a needle or pin and prick one of the balloons. The air will escape from the balloon. After the balloon is pricked, you will notice that the stick tilts towards the side of the air-filled balloon. Fig B. This happens because the balloon with air in it has weight, whereas the punctured balloon has no air and therefore no weight. Conclusion: this experiment shows that air has weight, as the stick tilts towards the balloon that still contains air. Exerts pressure. Since air occupies space and has weight, it also exerts pressure. The pressure exerted by air is called atmospheric pressure. Importance of air pressure. Air pressure helps us drink a liquid through a straw, fill ink in a fountain pen, draw medicine into a syringe. Info corner. Atmospheric pressure is measured with an instrument called barometer. Let's do experiment. Materials required: a juice can, a screwdriver, a glass. Steps: take a juice can. With the help of an elder, make a hole in the can with the help of a screwdriver. Try to pour juice out of the can into a glass. Ask the elder to make one more hole, a little away from the first hole in the juice can. Now try to pour juice out of the can into the glass. Observation: you will observe that in the first case, when the can had one hole, juice was coming out very slowly. However, when 2 holes were made, the juice flowed out rapidly. This is because air enters through the second hole, and its pressure pushes the juice out of the can quickly. Water. Water is the second most important need for life on Earth, after air. It is essential for all living beings, humans, animals and plants, to survive. About 3/4 of the Earth's surface is covered with water. However, Only 3% of all this water is fresh and safe for drinking. The remaining 97% is found in the oceans, but it's salty and not fit for drinking. That's why we must use water wisely and not waste it. Impurities in water. The water we get from sources like rivers, ponds and lakes is usually not clean. It often contains mud, dirt, germs and other harmful substances that make it unsafe to use or drink. These harmful substances are called impurities. Impurities in water are of two types. Soluble impurities. These impurities mix completely in water and cannot be seen. For example, salt is a soluble impurity. Insoluble impurities. These impurities do not dissolve in water and can often be seen floating or settling down. For example, mud and sand are insoluble impurities. Removing insoluble impurities. Insoluble impurities can be removed using the following simple methods: sedimentation and decantation. When dirty water is kept still in a container for some time, the heavier impurities like mud and sand settle at the bottom. This process is called sedimentation, and the settled impurities are called sediments. After sedimentation, when the impurities have settled at the bottom, the clean water on top can be carefully poured into another container. This process is called decantation. Filtration. Sometimes, light solid impurities float in water and do not settle at the bottom. These impurities can be removed using a filter paper. This method is called filtration. For example, the mixture of water and sand is poured into a funnel lined with filter paper. On pouring the mixture, the sand stays on the filter paper. This is called residue. The clear water that passes through is called filtrate. Removing soluble impurities. Soluble impurities like salt or sugar can be separated using evaporation or distillation. Evaporation. In this method, water containing soluble impurities is heated. As the water heats up, it changes into steam and evaporates, leaving the impurities such as salt behind. Let's do experiment. Aim: to remove soluble impurities from water through evaporation. Materials required: water, salt, a burner and a beaker. Procedure: 1. Dissolve 2 teaspoons of salt in some water till a clear solution is obtained. 2. Heat the solution till the water evaporates completely. Observation: when the water evaporates completely, salt is left behind in the beaker. Conclusion: soluble impurities can be removed from water by evaporating it. Distillation. The process of purifying water by evaporation and then condensation is called distillation. Distillation process involves the following steps. Impure water is taken in a round-bottom flask and heated. On heating, the water changes into water vapors and the impurities are left behind. The water vapors pass through the condenser. It cools them and turn into water again. Pure water collected by this process is called distilled water. It is the purest form of water and does not contain any impurity. Purification of drinking water. It is important to drink clean and safe water, as dirty water can cause diseases. Here are some common ways to purify water. Boiling. Boiling water for at least 20 minutes helps kill harmful germs. It is the easiest and most common method to make water safe for drinking. Chlorination. A chlorine tablet can be added to water to kill germs. It is a quick method to purify water, especially in emergencies. Water purifier. Electric water purifiers like RO filters are used in many homes. They remove both dissolved and undissolved impurities and give us clean drinking water. Quick recall. We cannot see air, but we can feel it when it blows. The blanket of air surrounding the Earth is called atmosphere. The atmosphere has 5 layers: troposphere, stratosphere, Mesosphere, thermosphere and exosphere. Air takes up space, has weight and exerts pressure. Soluble impurities can be removed by evaporation or distillation. Water can be purified by boiling, adding chlorine or using a water purifier.